We've developed the next generation of 5G connected devices, where the device not only collects and relays critical information to the city, but it also equips the user with one of the leading AI engines to inform them of their surroundings. Our project centers around the need to make micromobility safer and encourage people to use this form of transport more often. We define micromobility as bicycles, e-bikes, scooters, mopeds, etc. Micromobility users are some of the most vulnerable on the road and least protected. This has led to a reluctance on many people's part to use this type of transportation for anything more than recreational use. The traditional approach of creating specialized lanes for micromobility use are not always very achievable, and even in the best planned road systems, there is inevitably a direct interaction between micromobility users and automobiles and trucks. To avoid this interaction, some riders are turning to the sidewalk as a means of escaping this interaction. However, this brings micromobility users into direct contact with pedestrians. This has led to fatal outcomes, such as the recent incident in London, UK, where a pedestrian was struck and killed by an e-scooter. The introduction of electrical technology to micromobility vehicles has offered the opportunity to open this form of transport to more users. However, it has also increased the average speed of a vehicle, such as a bike, by 50% and increased the opportunity for more severe accident for the rider. We designed the device that is attached to the bicycle and made this device capable of being self-aware of its surroundings, much like the safety features of an automobile. The device is an AI engine computer coupled with a camera that can identify, classify, and predict the path of any vehicle or object that is in the field of view. These devices can be mounted facing in any direction, but are normally positioned to face the area behind the rider where it is difficult to see. The device name is the Foveae, and it learns the owner's patterns and can communicate with them about their surroundings. The device sees the surroundings and can identify what it sees through computer vision. It also is able to determine the location of the vehicle with relation to the rider and calculates the speed and direction of travel of the vehicle. The intelligent tracking is possible with multiple vehicles in a single frame and can be used to aid the rider in understanding traffic conditions behind them. The device will be integrated into 5G networks in the second release and is aimed at being adopted by mobile carriers as part of their ecosystem. The first version of the device is connected to the rider through the rider's phone and wearables, and it can provide information both visibly and audibly to the rider. Micromobility users generally use parts of the road system, the edge of the road, that are not in normal use by other vehicles such as automobiles. Our device captures the condition of this part of the road infrastructure through our video technology, and we are creating libraries for the device to recognize conditions such as potholes, ice, etc. This data can be made available to other riders and to the city to help with maintenance, planning, and route selection. Our first product features are intelligent information to the rider for their surroundings, including classification of objects and warnings. Warning signals from the device to vehicles behind the rider, such as a stop, slowing light, turning signal. A black box feature that stores the last 20 seconds of video in the event of an accident. And road condition data generated by the device that can be supplied to any other user and to the city. Cities are trying to encourage more environmentally oriented habits from their citizens. Activities such as cycling have multiple benefits to a city. It promotes a less polluted way for people to move around the city, and it helps promote a healthier lifestyle for its population. To achieve these goals, a city must tackle the issue of rider safety in multiple ways. One angle is to ensure that roads are designed to promote a safer experience for the riders. Another is to equip the rider with information about their surroundings, covering natural blind spots that they have, mainly to the rear of the vehicle, and allow them to create a virtual safety zone for themselves. The device that we have created uses computer vision and a local AI engine to recognize the road and vehicles around it and communicate to the user through a near-field communication connection through the phone. Coupled with this AI engine is an accelerometer and an LED array. The LED array is used to inform other road users of the rider's intentions, such as indicating for a turn or braking. It is able to communicate to the drivers if they're getting close with a set of emoji faces. The accelerometer is used in the event of a crash, and if the accelerometer experiences an impact, it triggers the device to store the last 20 seconds of video. The complete package is battery powered and will last for over 4 hours on a single charge. The addition of 5G connectivity will allow the device to interact directly with infrastructure through the carrier's network. This will require a SIM card and a radio to be incorporated into the device and a connected device plan to be purchased from the mobile carrier. Data from the device can be streamed directly, and as cities become smarter, this will allow the device to interact with infrastructure such as traffic lights, street lights, and receive road data from the city. For example, knowing there is an emergency ahead and rerouting a user to a safer route. This application is in demand by mobile carriers around the world, and we are already seeing this being planned for in some of the more 5G developed economies. We're currently in the industrialization phase of the product. We've developed many generations of prototypes and fixed our design and form factor. We've now won 5 design awards for the device, including the Red Dot Award 2021 Concept Design, and we are being awarded the Paris Design Award Grand Prix today. We now must industrialize the software, the app on the phone, the PCB, and the case to make it hardened for consumer use. Once we have our first product, we will move swiftly to equip the device with 5G connectivity. The benefit of this capability is that the device can communicate with the city infrastructure and other road users directly without the use of a phone. This will elevate the device in terms of its availability to connect and participate in the infrastructure development of the city. The company has been self-funded to date. To move through industrial design and manufacture phase for the solution requires the injection of capital and partners to help us through this process. We're interested in partnerships with technology companies that can help our evolution, manufacturers that can assist in the design for manufacture, and cities that can partner with us on both trialing user groups and helping us achieve funding. So in conclusion, thank you for taking the time to listen through our presentation. We're really hopeful we can find partners to help us on our journey, and we'd like you to reach out to us. You can contact me at chris.stark@satellite.com or on my phone on 214-558-9232.